Hello friends, welcome to Risingpearl.com. Today we are talking about series 13 where we are learning a great deal on surface areas and volumes. This is webisode number 18 and friends we are going to continue to find out how to solve questions that involve calculating volume of combination of solid figures. This is part 4. In the last few episodes we have talked about part 1, 2, 3 where we have looked at how do we solve these questions, and we are trying out more and more complex and difficult questions with every webisode. So let's just quickly refresh what is our overall strategy in solving these questions. So it's a three-step strategy. The first step is we try and visualize which simple solid figures, by that we mean cuboids, cubes, cylinders, cones, spheres and hemispheres, which simple solid figures they make up our given complex shape or the solid. That is the first step. The second step is to find out which volumes we actually do need to add and which volumes we may need to subtract to find out the required volume which is given in the question. And third and final step is that we find the volumes of these individual solid figures. Now you recall that in our earlier grades we have learned how to find out the volume and surface areas of cuboids, cubes, cylinders, cones, spheres, hemispheres, etc. We are going to use those formulas to find volume of these individual solid figures that make up our complex figure. And then using step 2 we will say which volumes we add and or subtract. By applying that we will find out the required volume that we need to find in the question. We have seen and applied these steps in the last few episodes as well, as we have been looking at these questions. So we are going to take more questions in this webisode. So the question number 4 goes like this. A solid iron pole consists of a cylinder. So looks like we have one cylinder whose height is given, height 220, and base diameter is 24. So we have a cylinder whose height and diameter is given, now which is surmounted by another cylinder. So we have one cylinder, this is the base cylinder, and then we have another cylinder on top of the base cylinder, and this cylinder's height is given and its radius is given. So looks like we have one cylinder on top of another cylinder and the height and radius for both of them are given. So what do we have to find out? We have to find out the mass. This is kind of unusual because usually we have to find out the areas or the volumes. So here we have to find out the mass of the pole, given that 1 centimeter cube of iron has approximately 8 gram of mass, and we have to use pi equals 3.14. So this is an interesting question. So what is given? The first thing is that we have to clearly visualize how our cylinder looks like, one cylinder on top of the other. And also looks like what we have been given is we have been given 1 centimeter cube of iron. It actually weighs 8 grams. So seems like we have to find out x centimeter cube, whatever is the volume, and then for 1 centimeter cube, if it weighs 8 grams, for x centimeter cube, what is x? X is the volume of iron that we have. Looks like we have to find out this, then that will actually weigh 8 times x, this much gram. So this is what we have to do. So now let's look at, so we have one cylinder and then we have one more cylinder on top of it, and it looks like what is given is that for the bottom cylinder, so this is the radius, let's say this is R1, and this is the height of the bottom cylinder, let's call this H1. And for the small cylinder, let's say this radius is R2 and this height is H2. So we have been given these values. So the base cylinder height is 220, and this radius, the base diameter is 24. So it means twice R1, which is the diameter, will be equal to 24. So from here we can say R1 is equal to 24 by 2, or it is simply equal to 12 centimeter. So R1, this is actually equal to 12 centimeter, and similarly the top cylinder is height, this height is given as 60 centimeter. So this is 60 centimeter and this radius is given as 8 centimeter. 8 centimeter. So we know, friends, that the only two measures for any right circular cylinder we need, they are the radius of the top and bottom circle of the cylinder and the height. So we need the R and the H, and it looks like for both of them it is given. So to find out the mass, first we have to find out the volume. That is, we have to find out the amount of iron which is inside this, and similarly the amount of iron which is inside this. Make sure that you follow this, because this is a solid iron pole. This is not like a hollow wooden block or something of that sort. It is full of iron. So we want to find out the volume of iron inside the base cylinder. We want to find out the volume of iron in the top cylinder. Then, so if the volume of iron in the base cylinder is V1 and then the volume of iron in the top cylinder is V2, so we will add these two to find out the total volume, what we are also calling this as X, right? Once we find out the total volume, then for 1 centimeter cube, because all the measures are in centimeter, so V, the value we will get will be, or the X will be X centimeter cube once we find out the volume. And once we have this, we know 1 centimeter cube is 8 gram. So X centimeter cube will be 8 times X, whatever the value of X is. So that is going to be our overall strategy of how we are going to solve this question. So we need to find out the mass of the iron. It is given 1 centimeter cube of iron is equal to 8 grams. We need to find out the volume of the iron pole. So the volume of the iron pole will be, as we discussed, volume of the base cylinder plus volume of the, this should be top cylinder, right? So now if we have to calculate the value, so what is the formula to find out the volume of the base cylinder and the volume of the top cylinder? We know that the formula to calculate the volume of a cylinder is basically pi r square h. This formula gives us the volume of a cylinder, where r is the radius, so r pi r square times h. H is the height. So the volume will be equal to, so let's write these values. So here this we saw for the bottom circle, the bottom cylinder, this was actually 12, and this height is given as 220. Now this radius is given as 8 and this height is given, I think, as 60. So the formula is pi r square h. So for the base cylinder we can say pi, what is the value of r? R is 12, pi r square times h is 220, plus it will be pi r square for the small circle, r is 8 square and h is 60. So what you can do from here is that you can say pi, you can take pi common and then you can actually multiply. So 12 square is this times 220 plus 8 square is 64 times 60. So I'm not going to actually do this calculation, and it has been said in the question, use pi equals 3.14. So if you find this out and if you put pi equals 3.14 and find it, you will get a number, and let's call that x. So you will get x centimeter cube, and that is what we have been discussing, that once you get the volume of iron in this solid, if that is x centimeter cube, we know that 1 centimeter cube of iron, it actually weighs 8 gram. So x centimeter cube, and remember that you know the value of x because you would have found that out. So x centimeter cube of iron will weigh 8 times x gram, and this will be your answer. So friends, this is how. So we use the fact that we figured out what shapes make up our solid, because this is a solid which is made up of two cylinders, 1 and 2. Then we looked at which volumes do we need to add, because one cylinder sits on top of the other one, and we have to find out the total weight of iron. So we have to find out the total volume of the pole. So we have to add both the volumes. And then the third step was that we found out individual areas by using the formula pi r square h. We found out this volume, we found out this volume, then we added them. That is how we got x. And then this question had an extra twist that find the mass. So the mass we have to find out, because it is given 1 centimeter cube basically weighs 8 gram. So x, whatever the value that you come up with, x will weigh 8 times x gram. Let's take a look at one more question before we wrap up. So let's say a solid consisting of right circular cone. So now we are describing the solid here. Consists of a right circular cone. So we have a right circular cone of certain height, the height is given, and a certain radius is given, standing on a hemisphere. It looks like our solid has a top cone and a bottom hemisphere whose radius is given. Important to note that the radius is the same. So our right circular cone radius is 60 and our hemisphere radius is 60 as well. So this solid that we have, this solid is actually placed upright inside a right circular cylinder. This is interesting. So we have a solid which basically the top part of the solid is a cone and the bottom part is a hemisphere. All the measurements are given. That solid is kept upright, meaning it is just kept straight, right? So if you think about a person, this is a person standing upright, and this is maybe a person who is lying down, or the person basically is now lying down horizontally. So upright means standing straight. So now if we place this solid upright straight inside a right circular cylinder which is full of water such that it touches the bottom. When you put it, it touches the bottom. So find the volume of water which is left in the cylinder if the radius of the cylinder is 60 centimeter and the height of the cylinder is 180 centimeter. So it looks like all of the measures are given. So let's first draw our cone. Here we have the cone, the top part, and the bottom part is the hemisphere, and we join them. So this is our solid. So this actually shows our solid. So this is the cone, right? And this is our hemisphere. So in short, I'll just write it like this. So this is our solid, and what we are doing is that we are taking this solid and we have a right circular cylinder. This is a right circular cylinder, and this cylinder is filled with water. So maybe I'm actually drawing like this to show you that this is full of water, right? So think about like maybe some sort of a tank, a water tank or something like that. So this cylinder is actually full of water. So obviously when you place this solid inside the cylinder, what will happen is that you will have some water that will spill out, right? So some water will come out, right? And then solid will go inside and there will still be some water left inside the tank or inside the cylinder. That is the question. Find the volume of water which is left in the cylinder, right? So in other words, our final state should look something like this. So here we have, basically this is the final, how it should look eventually. So this is all water. So inside the cylinder, part of the water will be still there and The rest will be taken up by the solid. So let's think and understand, how do we actually solve a question like this? So what is really going on is, first of all, we have to find out the volume of our solid. So this is a solid. We have to find out the volume of a solid. So we have actually volume of a cone. So I'm writing subscript cone, and we have volume of a hemisphere. So to find out the volume of our solid, we have to add volume of the cone plus volume of the hemisphere. This will give us the volume of the solid. Now, how do we find out the amount of water which is inside the tank or inside the cylinder? Remember that, as we have discussed many times earlier in the earlier episodes, that capacity of a container is really equal to the volume of the container. So the amount of water which is inside is equal to the volume of the cylinder. So we find out the volume of, let's say, this cylinder, right? So once we find out the volume of the cylinder, that is going to be equal to the amount of water which is inside. Now when you put the solid inside, let's call this like Vs, volume of the solid, or let's just write it like this for the time being. When you put that inside, obviously some water spills out, right? Maybe a lot of water spills out, but whatever is the amount of water which is left inside, right? If you say, let's say VW, or volume of water whichever is left inside, right, after you have placed the solid, then whatever the water which is left out inside, plus if you say the volume of the solid, right, which is this, if you add these two, they must be equal to volume of the cylinder. Or if you add the volume of water which is left inside plus the volume of solid, that must be equal to the total volume of the cylinder to begin with, right? So make sure that you are actually following this along. This is very important. Now let's actually write them step by step, right? So what we have is the volume of water which is left in the vessel, right, in our cylindrical vessel, is really volume of water which was initially present in the vessel minus the volume of cone plus hemisphere, which is exactly what we saw, right? So the volume of water which is left plus the volume of solid is equal to volume of the cylinder. That is what we just saw, right? So then volume of water will be nothing but the volume of solid will go on the other side here. So it will be volume of cylinder minus volume of solid, which is exactly what this is, right? So the volume of water left in the vessel or in the cylindrical tank will be equal to volume of water initially present, which is the volume of solid, right, the volume of the cylinder minus the volume of the solid, which is basically a combination of cone and hemisphere. So now let's see if we were to actually solve this. So what is the volume of water which is initially present, which is equal to the volume of the cylinder, right? So this was equal to, how do we calculate? So the volume of a cylinder is pi r square h. So all these values are given, right? So if you look at, this is a right circular cylinder, right, and it is full of water such that it touches the bottom. Find the volume. So the radius of the cylinder is 60. So if you think like this, so this is the radius and that is equal to 60. So we will say pi 60 square, and the height is 180. So this is the height. This height is 180. So pi 60 square times 180. So whatever this value is, this is the volume of cylinder, and which is equal to the volume of water which is initially present, or the capacity of the cylinder or the volume of water initially present, right? So I'm not going to actually solve this, but this is the amount. So this much, all the units are centimeter, so this much centimeter cube. Now the next step is to find out the volume of the solid, which is, we have a cone and we have a hemisphere. So if you simply add these two, so the volume of the solid will be, cone we know is 1 by 3 pi r square h, plus volume of a hemisphere, again the formula is 2 by 3 pi r cube. So this r refers to the hemisphere, the radius of the hemisphere, and this r refers to the radius of the cone and the height of the cone, right? So they may not be same all the time, just important distinction to make. So in this particular case, we know that the radius is same in both cases, so this and this value are the same. And what is the height? Let's see if that is also given, because we absolutely need to find that. Cone whose height is 120. See, the height of the cylinder is actually 180. The cone is actually 120. So our diagram is probably not very accurate. It is not like the cone is touching the top, right? So this is all water. So this is all water everywhere. So our cone height is also given. This is all the water everywhere. So now let's just plug the values in. So we have 1 by 3. And this is really the step 3 of our process, right? Where we find out the formula for individual volumes and we put that in. So 1 by 3 pi, r is given as, the radius is 60. So it will be 60 square times height is given as 120 plus 2 by 3 pi, r is 60 cube. So again, I'm not actually going to be solving this for you, but you can simply solve this, right? And then, so whatever the value we have obtained earlier, we use that and we subtract this value from it, and that will give us the volume of water which is left in the cylindrical vessel. So this one will be the volume of water that we would have found out earlier, which is equal to volume of cylinder minus the volume of solid that we would have gotten from the last step. So this is going to give us how much amount of water which is left in the tank. So this actually volume of water is the amount of water that you had that we had earlier, which is equal to volume of the cylinder. So friends, this is how you actually solve these questions step by step.